So in the previous video, we were kind of deriving a couple of the formulas from polar to for a complex number. So whoops, I don't know what I'm doing. So here we have the formulas, and we're going to do a couple of examples. So keep in mind that cis is just an abbreviation for cosine theta plus I sine theta. Okay, so just keep that in mind. And there's an R right in the front. Okay, so here let's express the complex number using polar form. So z is equal to 4i. So in this case, what we want to be able to do is think about what exactly is going to be your r. So you want to make it in this form. So you want to write this as z is equal to r cosine theta plus I sine theta. Okay, so you want to write from here to here. Okay, so there's a couple things that I need to figure out. I need to figure out what r is, and I need to figure out what theta is. So those are the two things that I kind of want to figure out. So first, let's figure out what r is, because r is going to be super easy. R is equal to the square root of x squared plus y squared. Okay, so in this case, let's think about what x is. So x in this case, so remember, you have it in the form of z is equal to x plus yi. So notice here that there really is no there's no x value, right? Here you have 4i, okay? So x is just equal to 0 here. So 0 squared, and then your y is going to be this 4. So that's going to be this 4 squared. So what you're going to get is square root of 16, which is going to give me 4. So your r value is equal to 4. Okay, now what about your theta value? Okay, so your theta value can be it really just depends on what you wanted it to be. Because you can literally use these values, or you can use the fact that tangent of theta is equal to y over x. So here's where you might want to bring that in. Another way that you can kind of think about it is think about graphing this guy. So for I, so here is the real part, here is the imaginary part. 4i is going to be right over here. So if you think about it, what is going to be this angle? Well, this angle theta is a 90-degree angle, okay? So theta here is equal to 90 degrees, or pi over 2, okay? So let's keep it in radians. So in this case, it's going to be pi over 2. So let's go ahead and do that. So we're going to keep it this way. So another way that you could have done is use tangent of theta is equal to y over x. So tangent of theta is equal to y. So remember, y in this case is going to be the 4 over x, which is 0. So this is undefined. So you're looking for what value of theta gives you something that's undefined, and that's going to be a pi over 2. Okay, and the way that you remember that is, remember that when we're drawing tangent, you have asymptotes at negative pi over 2 and pi over 2. So pi over 2 is actually one of the quadrants, or it's actually one of the angles where this is going to be undefined. So the way that you write this, so let's write it in this notation, is z is equal to r. So r in this case is equal to 4. Then cosine of pi over 2 plus I sine of pi over 2. So this is basically the polar form of the complex number. Okay? So this would be it. Or you could have just written it as z is equal to 4 cis pi over 2. There's another way that we can do it. Okay? Alrighty. So now let's do this guy. Oops. Went too far. For this one, remember, to convert it to polar form, you want to find what r is, and then you want to find what theta is. So let's first start off with r. So we know the formula, r equals square root of x squared plus y squared. So x squared in this x is going to be this negative 4. And then the y is going to be this 4. So you're going to have the square root of 16 plus 16, which gives me the square root of 32. Okay, so then I'm going to take the square root of 32. That's going to give me 4 square root of 2. Okay, so that's the value of r. And now we need to figure out what theta is, okay? So let's use the tangent of theta equals y over x. Okay, so y in this case is this 4 divided by negative 4. It's going to give me negative 1. So we're going to take the inverse tangent of negative 1. Let's make this one into degrees, okay? That way we get some um, how do you say some practice with degrees and radians. Okay, so I get negative 45 degrees. Now you have to be very careful with this because you want to make sure that you're in the right quadrant. So because remember that tangent is only between negative pi over 2 and pi over 2, the inverse tangent. So let's think about where exactly negative 4 plus 4i is. So negative 4, okay, so it's going to be negative 4. So negative 4 this way, and then positive 4i up. So basically this is in quadrant 2. So right now what the angle that we got was this angle down here. So, and that's not quite what we want. We want this angle right over there. So all we got to do to get to that point is just add 180 degrees. So we're going to add 180, okay? So we're going to take this 180 and add it to negative 45 degrees and gonna get 135 degrees. So that is a true angle. So in order to find the angle theta is twofold. It's basically solving for the angle theta using tangent theta and then being able to graph it just to make sure that you actually have the angle that you want. Okay, so now all we got to do is just write it in polar form. So z is equal to r cosine theta plus I sine theta. So this is going to be equal to 4 square root of 2 cosine of 135 plus I sine of 135. This is in degrees. Okay, and obviously you could have written it as 4 square root of 2 cis 135 degrees. You could have written it like this. Usually the problem will tell you if it wants it in radians or degrees or in both. So, and if it doesn't give you something, just you can do whichever you want. Okay, I don't really care about this one. But usually like on your homework, it'll tell you use degrees or radians for WebAssign. Okay, so let's use a different color. Okay, so let's do a couple more. So z is equal to 3 plus 3i. Okay, so r is equal to square root of x squared plus y squared. Okay, so we're going to have 3 squared plus 3 squared. That's going to give me 9 and 9, which gives me 18. Okay, and then we're going to take square root of 18, which is going to give me 3 square root of 2. So that's the value of r. And then we're going to use tangent of theta. So let me just write it like this. Theta equals tan inverse. So that's basically what we're doing. And then y over x is going to be 3 divided by 3, which is going to give me 1. This is going to give me 45 degrees. Okay, now is this the correct angle? Well, let's graph it. So we know that this is 3, and then here's 3i. So it's in quadrant 1, 45 degrees is in quadrant 1. So this is going to be z is equal to r, 3 square root of 2, and let's just write cis of 45 degrees. Okay, and if you wanted to write pi over 4, you could have written pi over 4. Okay, so let's do one more. Okay, so z is equal to negative 1 plus square root of 3i. So let's start off by writing r is equal to the square root of negative 1 squared plus square root of 3 squared. So this is going to give me 1 plus 3, which is going to give me square root of 4, which gives me 2. So that's the value of r. So, okay, and now let's figure out what tangent theta is. So theta is equal to the inverse of y over x. So that's square root of 3 over negative 1. So tangent inverse of negative square root of 3. Okay, so when I do that, you can have your unit circle handy because this is going to be in the unit circle. This is going to give me negative 60 degrees. Okay, so now this is not in the correct format because you have negative 1 over here. Whoops, that's wrong. Negative 1 is way out there. So here is negative 1, and here is positive square root of 3i. This is in quadrant 2. I got negative 60 degrees over here, so I got to add 180. Okay, so I'm going to take 180 plus negative 60. That gives me 120. So that means that r is, oh, that's wrong. That z is equal to 2, let me write it like this, cosine of 120 degrees plus I sine of 120 degrees. Okay, or cis of 120. Okay, so that's basically what it would be. Now, be very careful because there's going to be problems where you have to write them. How do you say it? Where sometimes when you find the tangent of theta, it's not going to give it to you in the unit circle. So far, all of these angles have been really nice, but be ready to find the tangent or the arctangent of 2, for example, where it's not in the unit circle. So remember, this would be the exact answer. And then approximate answer, if you want the approximate, basically that's when you're going to put it in the calculator. So just keep in mind that not all of the questions or not all of the when you find the value of theta, they're all going to be nice. Okay, so just keep that in mind.